This is a short video on how to do this, Punnett squares. We're going to do a monohybrid cross. We're going to assume complete dominance. Brought to you by Curious Moranland. So let's take a look here. If you're my student, first thing I want you to do is copy down the steps. Now I'm going to repeat these steps a couple times. So first, you got to identify the alleles. What does that mean? Well, take a look. This letter H doesn't mean anything if you don't know what the H represents. Alright? So we're going to do a traditional earlobe thing here. So we got our dominant trait and our recessive trait. We know it's dominant because we're going to designate it with a capital letter H and a lowercase h. Traditionally, when we write allele pairs, we will write the capital letter or the first, and we'll write the lowercase letter. So sometimes people will do F and little f for the free earlobes. So the trait is the shape or of the earlobes. The variation, the alleles, are free versus attached. So the first step was identify the alleles. The next step will be to identify the genotypes of the parents. It doesn't mean anything if you don't know how to identify the genotypes of the parents. So here's the genotype. So I'm going to go back to this one. So we have a free earlobed parent times another free earlobed parent. You'll notice there's no reference to gender. You can't tell the sex of the parents. We'll talk about sex-linked traits and complex patterns later. So the second step was to identify the genotypes of the parents. So we're going to cross this one times this one. So how do you do that? Each parent sends half their genes. So take a look at the next slide. So we put one parent on the top, one on the bottom. Okay? So I'm going to do something different. I'm going to show it filled out, but what I'm going to do is go right to a video that I made before. And I'm going to hit play, and it's just going to walk through these steps. So I'm recording a recording made by me. You'll notice as we go through, I put a bunch of little ones to show that the H moves down, the blue H moves across. The big H, the black H, can also combine with the little h. Now the blue H can combine with the little h there. Now the two little h's can combine. The blue H and the black H. And I'm gonna pause it for a second. Go back to this. What's the next step? A lot of students can fill out Punnett squares, but they don't know what to do after that. All right? This is the key thing here. This listing the genotypes and the phenotype ratios. And they should confirm each other. First off, if it's a box of 4, your number should add up to 4. So let's do this. I'm going to show the video again, and I'm going to pause it. All right. Pause it for a second if you need to, and take a look and see how we've separated. So the blue H, capital H can combine with either one of the other black inked H. The lowercase h can combine it. So what is a Punnett square? It's a prediction of possible combinations of egg and sperm. Now, I was running out of space, but you'll see where I wrote gene, that means genotype, and look at my little bracket. It's a 1-to-1 ratio for this cross. These are not the only crosses that you'll do. So I'm going to go ahead and close this video and proceed to where I already have it filled out. So that's pretty much it. Identify the genotypes. Identify the alleles. Identify the genotypes of the parents you're crossing. Fill out the Punnett square. List the genotypic and phenotypic ratios. One last thing about this is you'll notice this 1 and 2 add up to make the 3 phenotypic ratios. They should verify each other. This should add up to 4. This should add up to 4. This should have representation in the genotypic numbers. this should have representation in the genotypic numbers. Brought to you by Curious Ramland. And that's a short little thing on how we do Punnett squares.